All right, let's look at homework exercise number 1 from section 5.4. It says evaluate the following expression, the square root of 16. Now, the definition of the square root means what number times itself gives you the number inside the square root. Now, once you do it, you lose the radical sign. So this is called the square root sign or the radical sign. Now, we have 16 here. We ask ourselves, what number times what number equals 16? You can probably figure this out in your head that 4 times 4 is equal to 16, or 4 squared equals 16. That means that the square root, since 4 times 4 equals 16, it's kind of the inverse operation. Because the number squared is 4 squared is 16, that means the square root of 16 is 4. Okay, now you don't leave a radical sign. Even though the square root of 4 is 2, you don't do it twice, you just do it once. So the square root of 16 is the whole number 4, and that's it. No radical sign. You performed the operation, the square root, here, so you lose your radical sign. Okay, so your answer is simply 4. What number times itself gives you the number underneath the radical? Now, okay, let's go ahead and put this answer in to verify we're correct, which we are. On the calculator, the square root key is in blue on the x squared. Okay, it's in blue on the x squared, or on the TI-83 it's going to be in yellow. So you will hit the second key, and then you will hit the x squared key, and you'll get the radical sign up here. Okay, and then you'll put in the number underneath the radical. Okay, so let's go ahead and do it on the calculator. So we have second, and then the x squared, but it gives you the radical. Okay, then you can input it underneath the calculator, underneath the radical sign, put in 16, and then you hit enter, and there's our answer 4. Okay? Okay, square root of 81. What times what gives you 81? It's 9, right? So again, on the calculator, second, x squared, and it'll get the radical sign. Put in 81, and you get 9, because 9 squared is 81. So the square root of 81 is 9. Okay, now we definitely use a calculator to find a decimal approximation for 1,787. To the nearest tenth, which is 1 decimal, hundredth is 2 decimals, and thousand is 3 decimals. So again, second square root, and then the number is 1,787, and we hit enter. Okay, and to the nearest tenth is 1 decimal place, correct? So to the nearest tenth, we have what? A 2 followed by a 7, so we would round up to 42.3, right? Nearest tenth. Nearest 100th, a 2 follows the 7, so we would round down or keep it to 42.27. Thousandth is 3 decimals. 2 is followed by the 9, so we would round it up. The 2 would become, there would be 27, and then the second 2 would become a 3. So this is to the nearest tenth, 100th, and 1,000. All right. 42.3, 42.27 to the nearest hundredth, and 42.273. You keep all the decimals to the left, and then you round off thousandth as the third one. It followed, the third was followed by a 9, so it rounded up. All right, now, we do not want a decimal for the square root of 50. So this one you have to do pencil and paper or by hand. The calculator will not help you unless you're just breaking it down. So what we're doing here is square root of 50 is, if you do the prime factorization of 50, you can do that on your calculator due to divisions. 2 times 25, 25 is 5 times 5. Now, So the square root of 50 is also the square root of its prime factorization, which is 2 times 5 times 5. Notice, when a number occurs twice underneath a radical, as it is the case here with the 5s, then it's a perfect square. See, what happens is you have square root of 2 times square root of 25, which you could split up as the square root of 2 times the square root of 25. The square root of 25 is a perfect square, so we have the square root of 25 is 5, so the 5 comes out. Usually we write it to the left, and then underneath the radical we're left with a 2. So 5 times radical 2. Now again, the rule is when it occurs twice, it's a perfect square, it comes out once. So right here, you can say there's 2 5s. So the 5 comes out once. That's the perfect square, and then the 2 is underneath the radical, and there's our same correct answer. Or you could get a big perfect square. You could say square root of 50 is square root of 2 times square root of 25. Split them up. Square root of 25 is 5, and then a 5 radical 2. So it's a matter of, if you go to the prime factorization all the way down, you may take a few more steps, but you'll still get the right answer. Or if you find the biggest perfect square, and as long as you do it correctly, you can get the correct answer that way. So either way is going to work. Okay? So just go ahead and start breaking it down, or find the prime factor, or to find the biggest perfect square, and you'll be all right. Okay, so again, the 5 is out. Now again, you don't need to use times. Now this, we're going to use the square root sign. This is an nth root. We're not doing nth roots. So the square root, again, the 5's outside the square root is a perfect square. So hit the square root. What was left underneath the radical sign or square root was 2. And there's our answer. You don't have to put it times. Okay, 108. All right, again, calculator won't help unless we're breaking down prime factorization. 108 is 2 times 54. 54 is 2 times 27. 27 is 3 times 9. 9 is 3 times 3. So what do we have here? The square root of 108 equals, we might as well just, probably don't need to use our exponents because we're gonna pull them out each pair. There's 2 2's and there's 3 3's. So it's 2 times 2 times 3 times 3 times 3. What's the rule? If it occurs twice, it's a perfect square. So square root of 2 times 2, square root of 4 is 2. It comes out. Square root of 3 times 3, square root of 9 is 3. It comes out once. What's left underneath the radical? Simply a radical 3. Now to get it correct in MyMathLab, you have to multiply the ones on the outside together. So 2 times 3 is equal to 6. 6 radical 3 would be our correct answer. Now 108, if you were clever enough, the biggest perfect square in 108 is 3 times 36. And then you would take, because 3 times 36 is 108, then the square root of 3 times the square root of 36. Square root of 36 is 6, and we're left with a radical 3, the same correct answer. So again, if you find the biggest perfect square, great. If you don't, you get all the prime factorization like we did here, write it over there, and when it occurs twice, it comes out once. You will still get the same correct answer. All right? So the good news is, as long as you do it correctly, there's several ways of doing this problem, or at least a couple different ways. Okay, 6 is on the outside. Then we choose our radical from the little course menu bar. 3 was underneath the radical. And there's our correct answer. All right, square root of 250. Again, 250, you can start the prime factorization any way you want. 10 times 25, right? 10 is 2 times 5. 25 is 5 times 5. Prime, 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 right? So 250 is equal to 2, or the square root of 250 is the square root of 2 times 5 times 5 times 5. 3 5's and 1 2. What's our rule? When it occurs twice, it comes out as a perfect square. So square root of 2 5's, which is 25, square root of 25 is 5, comes out once. What's underneath the radical? 2 times 5 which then you would have to multiply together. There's only one number on outside the radical, which is 5, and then 2 times 5 is 10, so it would be 5 times the square root of 10. And that would be our correct answer. So 5, and then we choose our radical, our root. 10's underneath the radical, and there indeed is our correct answer. Okay, 2 times the square root of 98. Now the 2's already on the outside, so you'll just bring it down. 98 is inside the radical, right? So 98 is actually 2 times 49. 49 is 7 times 7, right? So we got primes here. So we'll copy down the 2 on the outside. The square root of 98 we're going to rewrite as 2 times 7 times 7, right? There's our from our prime factorization. What's the rule? When it occurs twice, it's a perfect square. So square root of 7 times 7, square root of 49 is 7. So the 7 comes out, it multiplies by the 2 that was already there, and left underneath the radical, right? That's the perfect square, is that 2. So now we multiply outside the radical. The 2 times 7 is 14, and underneath the radical is simply a 2. So that would be our correct simplification, 14 times a radical 2. Fourteen's on the outside. Choose the square root, the third one down on the left, and we were left with, now I don't remember, what was it, a 2, I think? Yeah, there it is, 14 radical 2. All right, very good. We're going to stop this session here. If you have any questions, send me an email at tswers@hodges.edu, TSWIERSZ, or call me at 239-938-7805. If I'm not in my office, leave a voicemail. Thank you.